Hi everyone and welcome to this my video on solving polynomial equations. My goodness, yes, the excitement is palpable and so is my enthusiasm, which gets a bit weird really because I'm 147 years of age. But anyway, my name is Darren from Maffs Guru, M-A-F-F-S Guru. You say where? I go there, that little corner of the interweb, where you can get all of these videos, believe it or not, for the whole series of year 10, 11, 12 and whatever year you are currently doing mathematics in. Whew, that was a bit of a mouthful. Now, what am I going to do on this lesson? Well, it's right behind me. And you can download this all from Maffs Guru as well. So every video that's on there has downloadable lesson notes with everything I write on. Now, obviously, if you download them now and put them on your iPad maybe or your tablet, you can scribble all over them and add your own notes before you print them off, which makes them eminently more sensible and summary notes and whatever else you're allowed to do. Now, if you ever have any comments or anything you want to add, you can add them below on, YouTube, but we'll come back to it in a moment. I'm not going to read the learning objectives because I'll just recount them at the end, but fingers crossed, by the end of this, I'm going to get all of that done. Now, we have done a lot in previous videos relating to polynomials, and I got really rather excited with polynomial division, and then the factor theorem and remainder theorem, and now we're actually going to put all of that together, and we're going to put it into one nice package. Why? For those of you who are currently in year 10, if you are going to do this in year 11 and year 12, polynomials, division, and factorising and sketching graphs is all massively, massively important. And this is really the precursor. If you learn this now, when you do it in year 11, you'll get even better. And by the time you get to year 12 and you do all your VCE exams and all those type of things, you will absolutely smash it. All right. So, but practice makes perfect. I know that sounds really, really stupid. It absolutely does. So in the previous video, we looked at quadratics and how we solve them. And then we moved on to polynomials with higher degrees. And then we looked at sort of the factor theorem and remainder theorem. Why? Because the remainder theorem became really important. When something divides in a whole number of times, it becomes a factor. And that becomes important. Why? Well, with quadratics. Because, let's have a look. When we were factorising and solving the quadratic that's behind me, what did we end up trying to do? Well, we were trying to put it in two brackets, yes? But what did those brackets actually stand for? Well, if you've watched the previous video, you'll now know it says it's a linear factor. And two linear factors that multiply together will give me my quadratic. Yay! But why do we factorise them? Because they show us where these points cross on the x-axis, yes? There are crossing points. This helps us sketch. But they also become our factors. And why are they our factors? Because they divide in with no remainder. This all gets big and big and big. And if you need to, go back and watch the videos again. As I said on mathsguru.com, really, really important. Now, I don't know if you have had me as a teacher before. Sounds random. But if you have, you'll know that I'll probably do this one using what we call the T method, where I draw a T and I multiply the coefficient of the x squared by that constant there, which gives me negative 40. And then what I do is find all the factors of 40. Now, other people use things called the cross method. So 1 times 40 is 40, 2 times 20, 4 times 10, 5 times 8. Now, you're going to turn around and say, why have I stopped there? Because when I multiply, well, although I'm looking to multiply these to make this top number, and we'll come back to the negative sign in a moment, I'm looking for a pair that when I add them together will give me that middle coefficient there. Now at this moment in time I've got 5 and 8. I'm looking for 3, so I know that that's got something to do with it. How do I get to negative 3 though? Because I've got 5 and 8, I want negative 3, then the chances are I would need to make that a negative. So I could make that whole side there a negative. And what we get now is that 5 times negative 8 is negative 40, but 5 minus 8 is negative 3. How does that help? Well, to do this the long way, if I had the x squared minus 3x minus 40 equals 0, the whole point of doing this is at the moment I can't actually factorise 3 terms. Right? I want to factorise in terms of pairs. So what I can do is I split this up now into, so the x squared stays the same, plus 5x minus 8x minus 40 equals 0. Now really all I've done there is to do this is I've taken this middle term here and I've split it up into 2. Why? Because I've now got 4 terms. Why is 4 terms useful to me? Well, so long as it's a factor of 2, I can start grouping. And that's what I'm going to do now. So let's have a look at grouping this. the first two here. What's the highest common factor of x squared and plus 5x? It's just x. So it becomes x plus 5. What's the highest common factor of minus 8x minus 40? Negative 8. Yep, negative 8. That gives me x plus 5 equals 0. Now again, for those of you who have had me will know that we are absolutely on the right track, because the whole point is to get those two brackets there the same. Why? Because I've got two terms, right? I've got something, they've got these two things here multiplied together, these two things multiplied together, and it's separated by a plus or a minus. So there's two terms. And when I've got two terms, what can I do? Factorize, because they've both got an x plus 5 in it. So what I'm going to do now is move my x plus 5 outside of a set of brackets, because that's what I'm really doing. I'm dividing both of those by x plus 5. And what do I get? Well, I get the x left and the minus 8, and that becomes equal to 0. So there we go. So what have I done? I've now turned my quadratic into the product of two linear factors. Linear because the highest floating number on each of those x's is a 1. What do I do now? Well, now we'd use the null factor law. Why? Because we know that when two things multiply together equals 0, one of them is 0 or both of them is 0. Okay, so therefore we get x plus 5 is equal to 0. That's one solution. Or x minus 8 equals 0. X is equal to negative 5. Or x is equal to 8. Now again, what do they mean? It tells me that if I was to sketch this graph, it would have a crossing point at negative 5, and it would have a crossing point at 8. I would know that it would have a U shape, and I could look at all my axes of symmetry and all those type of things and work it out. But the important thing here is we are going from a quadratic using some sort of algebraic manipulation, in this situation the T method, to get me a series of linear factors. Now, why are there only two linear factors? Because it's an x squared. What would happen if I had a cubic, an x cubed? How many linear factors do you expect we would get there? Well, hopefully we're going to end up with 3. Why? Well, if I was to draw a cubic, how many times are we expecting it to cross the x-axis? Well, there, on the whole, 3 times. It's not always the case, by the way, guys. But again, for those of you who are interested in shortcuts, what did you notice here? We had a 5 and a plus 5 in there, negative 8 in there. So I could have missed all of that working out and gone straight to this here, couldn't I? Well, yes, but only on monic quadratics. Now, if all of this is new to you guys, there are video on video on video on this on mathsguru.com that you can go back and watch, and I highly recommend it. If you're going to go on to higher maths later on, all of this becomes massively important, particularly the algebra, right? But the understanding as well. Okay, so there we go. That was factorizing a quadratic. How do we factorize a cubic? I need coffee.